Hello. Sorry, I am getting ready here. Okay, hi. This is my video lesson for a 7th grade lesson for probabilities. So as you can see, I'm sharing my screen because I'm going to have things that I want to show you as I talk about them, so you can follow along. As you can see, the total time for this lesson will be about 70 minutes, and let's begin. Okay, so the engaged portion will take about 5 minutes, and I'll begin by saying something like, "Hello class, let's get started by reading our objectives for today." The number 1, I will participate in games to investigate chance processes. So here I would have expected that all of the students in class are reading along out loud with the objectives that would be projected onto the whiteboard. So let's continue. Number 2, I will determine the probability of an event occurring using correct formulas. Number 3, I will speak using academic vocabulary by referring to chances and likelihoods as outcomes and probabilities. Next, I would project the following problem onto the whiteboard. 50 people are boarding a 50-passenger bus. All have assigned seats listed on their boarding passes. First person lost their boarding pass and took a random seat. After that, each person takes the assigned seat if it is unoccupied and a random unoccupied seat otherwise. What is the probability that the 50th person to board gets to sit in their assigned seat? And then I would say, turn to your neighbors and discuss this problem. Brainstorm if and how you could answer this question. So here I would be expecting that they would have no idea how to answer this question because we haven't covered this yet in class. So after about 3 minutes, we would return to the whole group to discuss some of their responses. And then to bridge into the explore portion, which will take about 15 minutes, I would say something like, okay, class, let's get ready to play a game. Get into your regular groups. Here, I'm assuming that they have like a regular group that they work with. So they would be working in groups of 4. And then I would give the instructions for the game, which is for this game in your group, 2 students are assigned as team 1 and 2 students are assigned as team 2. You're given 2 dice and you'll take turns rolling the 2 dice and recording the outcomes of each roll for a total of about 50 rolls. Number 1, 2, 3, or 4 is the greatest in the roll. Team 1 is the winner. If number 5 or 6 appears, team 2 is the winner. Work together to make predictions about outcomes of the rolls and whether or not one team has an advantage in the game. Kat has joined the meeting. Let's get her out. What is the probability she will come back again? I would say pretty high. After the game has been played about 10 minutes, I will say, everyone return to your seats and one person from each group return the dice to the box in front of the class. And let's talk about our game. Does this game seem fair? Do you think there is a higher, lower, or equal chance that one team will win a dice roll? Why or why not? Here, I would expect for them to have an idea that maybe the game was not fair because they would have played the game and found that someone had an advantage. One of the teams was winning more, and they probably aren't sure why at this point. So that will bridge us into our explain portion, which will take about 25 minutes. And I would transition to this portion by introducing the video I planned for the lesson and say, let's watch a video that might help answer some of the questions we have about our game. I'd project onto the whiteboard a video from Khan Academy explaining experimental and theoretical probability. See if we can get the video to play for us. We'll click. Here we go. Okay, I won't play the whole thing for us, especially because it doesn't seem to be loading. There it goes.
Is this strange that after 10
started at the last point?
Let's say that you've got a bag, and in that bag you put a bunch of marbles. Let's say you put 50 of these magenta marbles. 1, 2, 3, 4, 5, 6, 7. I'm not going to draw all of them, but you get the general idea. There are going to be 50 magenta marbles.
I'm going to skip ahead so we can kind of get an idea of what's in this video.
A magenta marble. There's 100 equal. And so let's say that after look, every time you put your hand at the back.
So this shows he's actually like explaining
and 3 blue.
Probabilities and working through some
Isn't a lot of experiment. Pause.
Sample problems.
Your hand in the bag. Let's say you get 8 of these would have been, and possible explanations for this. This I wouldn't have fretted about. After 10 experiments, not a big deal. But after
get to our lesson. Get back to our lesson. I apologize. This is taking me a moment. I have never shared one thing in a Zoom meeting, and I'm having trouble getting back. Okay. There. So we would have played the video, and I would follow with some questions to gauge and reinforce student understanding. I would display an anchor chart, which I have here, that basically describes the difference between experimental probability and theoretical probability and gives formulas for each and examples of each using coins, because coins are easy examples, easy to understand. Probably have one in your pocket or purse or bag or whatever that you can actually bring out for the students. Okay, so the anchor chart will stay on the whiteboard as we move into some guided practice, which I have some examples of the guided practice questions I would use here. And as the first two are just identify as either theoretical or experimental. The chance of rolling a sum of 4 with 2 number cubes is 1/9. So would we label this as theoretical or experimental? Well, let's look at our handy anchor chart and let's read the definitions for each. Experimental probability is found by repeating an experiment and observing the outcomes. So does this first one that I read, does it sound like that one, or does it sound like theoretical probability, which is what is expected to happen based on mathematics? I think that this sounds like theoretical. And in contrast, I drew 10 cards out of a deck and got hearts 2 times. Sounds to me more like experimental. It is, which is found by repeating an experiment and observing an outcome. Rather than just answering, I would wait for student responses, and we would be just the next set of guided practice are these are where we would actually work problems, and they are examples of each type. So after the guided practice, we will play a Kahoot game as a fun and engaging way to reinforce student understanding, pausing for positive reinforcement and guided practice opportunities. And I will say something like, let's play another game. In your Chromebooks, log into Kahoot and enter the pin projected on the whiteboard for today's Kahoot. Everyone is logged in. I'll say, let's play. After the game has been played, I will say something like, what is the difference between theoretical and experimental probability? Now that we have discussed the concept of probability, does the game we played seem more or less fair? Why or why not? I would expect students to answer at this point that the game was not fair because one team had an advantage or a higher probability of winning, and for them to also be able to explain which team it was. So to move into the elaborate portion of the lesson, I would transition by saying something like, now let's see if we can push our thinking about probabilities a little further. I would discuss with students less likely, more likely, and equally likely events and say, the probability of a chance event is a number between 1 and 0 that expresses the likelihood of an event occurring. Larger numbers indicate greater likelihood. A probability near 0 indicates an unlikely event. A number around 1/2 indicates neither likely nor unlikely, and a probability near 1 indicates a likely event. I want you to think about this and get with your seat partners. Work together to answer the problem projected onto the board. You will write your response on notebook paper and turn in one paper with both your names on it. And then here you can see is the problem that would be projected on the board. Suppose a paper cup is tossed in the air. The different ways it can land are shown below. Toss a cup 100 times and record each result. From this information, calculate the experimental probability of each outcome. Do the outcomes appear to be equally likely? Using experimental probabilities, predict how many times a cup will land on its side if tossed 100 times. So after working this problem for a few minutes, I would call for everyone to return to their regular seats so we could discuss the problem together. I would ask to hear some of their predictions. And then for the evaluate portion, which will take about 15 minutes, I would explain the instructions for the assessment and say something like, I'm passing out a worksheet. You will be working on this independently in class today until it's time to go. Then you will complete the rest at home for homework. You'll be turning it in tomorrow for a homework grade. You have about 15 minutes to work now, so make it count. And then a copy of our homework handout is here. And as you can see, it is full of probability questions. And then moving on to closure, which will take about 5 minutes, I would say something like, it's time to pack up and go now. Put your homework in your homework tab and don't forget to work on it tonight at home. When everyone is packed up, I would say, please give me a thumbs up if you feel that we met our objectives for today. Give me a thumbs down if you do not feel like we met our objectives or you have any lingering questions. Everyone gives a thumbs up. We would spend the remaining 5 minutes talking about what students learned or liked about the lesson. If there were thumbs down, we would spend the remaining 5 minutes answering questions and reviewing. And that is all. I want to show some of our work examples again. So we've got the guided practice and the anchor chart. A link to the video was up there. And then elaborate problem and our homework problem. I do also have a link to the Kahoot game. I'm not sure. I will add it, but so thank you. I hope you enjoyed my lesson. I'm looking for the stop button. Excuse me. There we go. Anyway, thanks again. That was my lesson.